So in this video, we're going to take a look at how to find the volume of a prism. So just to be clear, we mean by a prism any shape that has constant cross-section. So if I was to slice a shape, it would be the same shape running throughout it, okay? So all of the shapes we're going to have a quick look at, that is the same, okay? It doesn't matter which one of these you look at. If you sliced it through the middle, you would see that same shape. So a circle there, look, if it was a cylinder, or a triangle for a triangular prism, and so on and so on. Now, there are formulas for all of these, okay? And of course, we work out the area of that cross-section and then multiply it by the depth. So just to take a look at a few examples, in this cube, the cross-section is that front piece there. So if I was to work out that, it would be a squared. And then, of course, we have this depth going back, throughout it, this same shape. So we're going to be timesing that by a, of course, this is a cubed, right? And again, if we have a rectangular prism or a cuboid, well, this front cross section here would be a times b. We times it back by the depth. So, of course, our answer is ABC for this particular volume. If I have a cylinder, well, the area of that front section is a circle, so it's pi r squared. I'm going to be timesing that by h. So there's our formula, pi r squared times h, pi r squared h. In this triangle or triangular prism, right? Okay. Now, in this one, we've kind of been given the height, right? So if I wanted the area of a triangle, it's half the base times the height, half bh, right? But we can see that we have the length L going back, so we're going to times it by L. Our formula for volume is going to be a half BHL. Okay, so it's always the same. It's going to always be that exact same problem, right? We have the area of the front section times that depth. Now, let's go through some examples. So, we've got a lorry here. We're going to find the volume that this lorry can carry. So, it doesn't matter which way around we think of that cross-section. Let's do the 2.5 times the 2. We're going to get that and times it by how far along that goes, by 4. So, if I do 2.5 times 2 times 4, we are going to be left with 20. So we have 20 meters cubed. It's a cubic unit because we're dealing with volume. Right. Here, we need to find the volume of this cylinder, okay? So, also it says volume of water. So we might want to convert this to milliliters because water is mostly measured in capacity, which means liters or milliliters, but let's get to that in a minute. So, first of all, we need to work out the area of the cross-section, which in this case is a circle, look, okay? So that's going to be pi r squared. So that's pi times 10 squared, right? Because that radius is half the diameter, which is given as 20. So if I do that calculation, I'm going to end up with 314 centimeters squared. To find the volume, I've got to take my 314 and times that by that depth or that length, okay? So we're going to times that by 60. We are going to get 18,840 centimeter cubes. So if I want that in liters for water, well, I'll divide it by 1,000. It's going to be, let's say, 18.8 liters to 3 significant figures. Right, moving on. We have this particular example where we've got a traffic calming road hump, and it is this triangular prism shape. We've got to find the volume of concrete needed. So we're in centimeters here. So the area of this front section is a triangle, and it is calculated by doing a half times the base times the height. So a half, that's this triangle here, look, a half times 80 times 10. Well, that is going to be 400 centimeters squared. Then we times that by this length. So we're going to do 400 multiplied by 300. That is going to be 120,000 centimeters cubed. Okay, so again, if we want volume of concrete, concrete is poured, so we're thinking about capacity here. Let's change that to liters. So we'll divide it by 1,000. It's 120 liters of concrete if we're thinking of it in those terms. Either answer is fine. Now, with this next example, we have to think about this, okay? So we've got a cross-section of some guttering, right? So a gutter could be on a house. Let's imagine the gutter look like this. I mean, imagine it going on, okay? It's going to be a cross-section that is this trapezoid shape. So I need to work out the length of the the area of the trapezoid first. So to do that, I'm going to add together the parallel sides. So that's 10 plus 6. I'm then going to multiply that by that perpendicular distance between them divided by 2, right? So if I work that out, let's just do that. So 10 plus 6 is 16 times 5 and then divide by 2. I'm going to get 40 centimeters squared. But I'm told that I have 5 meters of this and I want to know the volume that will fit into that. So of course, I need to times it by 5 meters. But this is in centimeters squared. So I need to make sure I am working this out as in centimeters. So I've got to do 40 times 500. So if I do that, I'm going to have 20,000 centimeters cubed. If I want to work out the volume of water, I could do that in liters as well. It's going to be 20 liters. Okay, final example, we've got a compound shape that is the cross-section of this. It's a kind of an L shape, so I could work out the area of this by breaking into a rectangle and what looks like a square. So I'm going to have 1 times 2, which is 2 for that lower section, and then of course 1 times 1, which is 1 there. So my cross-section is 3. I've then got to do 3 times 15 for the volume, so that is going to be 45, and we're in centimeters, so my volume is in centimeters cubed. So we can still do this just the same if we have a compound shape. Okay, I hope that helps you to understand how to work out the volume of any particular prism.